Hey guys, in this video we're going to learn how to graph direction fields. The general first order differential equation has the format dy over dx equals f of xy. Dy over dx is the first derivative and it represents slope. F of xy is a function, which is a formula, that helps us find the slope at any point xy. We can find the slope by plugging in points xy, so just coordinate points, into dy over dx equals f of xy. To represent a slope at a point, we draw a tiny arrow at that point with the slope that you just calculated. Let's do a quick review of slope. If we were to have an arrow with a slope of 0, what would that arrow look like? Well, we know that a slope of 0 is a horizontal line. Let's say that the slope is 3. Well, we know that a slope of 3 is steeper than 0, so we just make our arrow more steep with a positive slope since it's positive 3. And then if you have a slope of 5, we just make this arrow even steeper than the slope of 3. No one is going to be measuring your arrow, like the angle of your arrows. As long as you show that your slopes are either increasing or decreasing, then you'll be good. If you have a slope of -1, then all we do is make the arrow have a negative slope, meaning it's pointing downward. And if you have a slope of -5, so it'll still be pointing down, but it will be more steep. Let's do an example of a direction field using what we just learned. So if we have a differential equation, dy over dx equals x plus y. So x plus y is our function of x and y. Dy over dx is our slope. So the best way to solve these problems is to make a chart. So in my chart, I'm going to make the left side be x values, and the y values are going to be on the top. The professor might give you a certain range, such as, or they might draw a graph for you, like a plot, and it might be from like -5 to 5, or from -10 to 10. I mean, that would be a lot of arrows to draw. So today I'm going to be doing only from -3 to 3 on the x and the y. I drew a graph over here because I was going to draw my slope field on it, but I'm going to end up using graph paper because it's easier to find your points and draw your arrows. I'm going to start filling in the first row. Our x value is going to be -3 and our y value is also -3. So we go to our differential equation dy over dx equals x plus y, and all we do is add our x and y together. So -3 minus 3 is -6. Then we move to the next column, to the right, and we do x equals -3, y equals -2. We add them together, and we get -5. And we keep doing the same process over and over again. We move to the right, we do x equals -3, y equals -1, and we get -4. So when you start realizing a pattern, our numbers are increasing by 1 as you move to the right, and you can just fill that in because you already know what they're going to be. There's no need to waste your time. Now we can move on to the next row. Our x is going to be -2, and our y is going to be -3. So -2 minus 3 is -5. Then we do -2 minus 2, and we get -4. Then -2 minus 1 is -3. So we see the same pattern again. Our numbers are increasing by 1, and we can fill in the rest of the row. We can repeat the same process for the next row. Now, if we look vertically, we can see that as we go down, the numbers are increasing by 1 as well. So we can just fill those in too. Now that we know the slopes at different combinations of points, we can start to draw our direction field. I like to first draw my arrows for the points that have a horizontal line. So that means that their slope is going to be 0. And we can see on this chart that there is a whole diagonal filled of points that have a slope of 0. So I'm going to draw those first. I like to draw tiny dots at the points where I'm about to draw my tiny arrows. That way it's easier for me to visualize where to draw the arrow instead of getting confused later on. So once I've drawn these points, all I do is draw a horizontal small little arrow at those points. Now it's time to fill in the rest of the direction field and draw the tiny arrows at other points on the graph. So if we were to go row by row, then our slopes would have to be increasing by 1. And it sounds easy, but once you start doing that for every single row, you actually get really confused. You guys can try it out, but I think the easiest way to do this is to look at the chart and notice where you have points with the same slope. So we actually have diagonals and diagonals filled with points that have the same slope. So some diagonals have the same slope of 0, some have they all have -1, or they all have 1. So we're going to do points with the same slope since they'll all have the same exact arrow. So now I'm going to draw the arrows for points that have a slope of 1, which includes the points 3, -2, 2, -1, -2, 3, and some more. So I'm just going to make the arrows slightly more steep. Now I'm going to draw the arrows that have a slope of 2. And these arrows are going to be even steeper. I'm going to repeat this for points with the slope of 3. You can also find some patterns in the direction field. As you go up from the arrow with slope 0, the slopes of the arrows are increasing, meaning they're getting steeper and steeper. So we can just fill the top part of the field without even looking at the chart. All we have to do is make the slopes of the lines get steeper. Now let's do below the points with the 0 slope. I'm going to look at the chart and see which points have a slope of -1 and draw an arrow with a slightly downward slope. The pattern that we saw on the top of the graph continues as you go down as well. The slopes of the arrows are becoming more and more negative, which means they're getting steeper. So you can just fill in the rest of the direction field without even looking at the chart. Our direction field is now complete.